Well, good afternoon, ladies and gentlemen. I'm here with you again in the remote mode. So today we will have the next talk about software systems design. Namely, we are continue considering various design patterns. Of course, you have already know my first slide from my talk. This is a standard slide that just introduces the idea behind design pattern. You can read it by your own. I'm sure you already learned these words by heart. Okay, this is the whole taxonomy. Again, I put this slide at the very beginning of my each talk. And today we will consider just one pattern, comment. Let me remind you that now we are considering behavioral group of patterns. That is the patterns that regulate or arrange the responsibilities between objects. Okay, so comment pattern. This is the formal definition of the pattern given by Erich Gamma. I have taken it directly from his book. And this description says that the common pattern encapsulates a request as an object. There are some consequences from this definition. If we if we encapsulate a request from a client as an object, we have some advantages. We can parameterize clients with different requests. We can make queues out of requests, and we can have, we are able to add some additional useful functionality to our design. Yes, this is a little bit unclear definition. As for me, when I first read this definition, I didn't understand it completely. So my idea for today is just leave this definition as is. Probably you would come back to this definition later and take the example, the concrete example of how this pattern can be used and which advantages does it provide to software designers. So look, the example is, just a moment, let me move the screen a little bit. So the example is a universal remote control. Of course, you use various remote controls in your life. The most popular example is just TV remote control, or, for example, in my apartment, I have an air conditioner, and I have remote control for that air conditioner. So this is a kind of well-known device. Typically, such a device has a number of buttons. Pushing buttons, you cause various actions. So we can say that each button on a remote control assumes some actions. So my idea in this example is to describe the programmable remote control so that the user, a client, can assign various functionality to buttons. So as I drawn here, functional buttons should be programmed to switch on a device. So this is the initial task description. So let's consider how to solve it. Okay, look at the slide. Here is the task definition. To connect an action with a particular button so that it's possible to control different devices uniformly. As I gave you an example with TV remote control and remote control that controls air conditioning. So the idea of this universal remote control is to be able to control various devices in your apartment, for example, or in your house. Okay, however, we have the problem. Look at the slide. The problem is that different devices has very different interface or API, whereas the remote control buttons assume the single unified interface. So the task actually is that we should harmonize the unified API of the device, of such a universal device, and different APIs of particular devices. So let's try to solve this task. First step. Let me move it again. The first step. We define the unified interface for all buttons, as I have already said. Look at the code snippet. Very simple class. It contains only one interface element, that is pure virtual function execute. This is pure virtual because there is a kind of exotic initializer equals 0. As you know, in C++, this is a so-called pure virtual function. That is, in other terminology, abstract function. To compare with other languages, such as Java, we can get the same idea. We can implement the same idea using interface. Look, this is absolutely the same, conceptually the same notation for abstract interface. So, okay, so we assume that our hypothetical universal remote control has this interface. Namely, each button has the same interface. It understands only one functionality, execute. Okay, let's go on. Look, how can we program the whole remote control as a whole design, as a whole device? For simplicity, I assume that our remote control contains just 5 buttons. Of course, we can generalize this solution for more buttons, and we do that today. However, for the first step, it is quite enough for us. This is, of course, a little bit simplified solution. So, our remote control device contains 5 buttons, and we have reserved the array slots, which each slot represents only one button. And there is a pointer from the programmatic point of view. There is a pointer to a command instance, the instance of type command. Coming back to the previous slide, command is abstract class, as you might understand, or interface if we take Java. This means that there are no instances of that class just because it is abstract. But nevertheless, we can make pointers to abstract classes. This is by the language definition, by the C++ language definition. We have constructor. We have initialized all buttons. We assign null pointers to slots. And look carefully at what I have written after that. Set function. What does it do? It accepts 2 parameters, pointer to an instance of a class derived from command, and the number of the slot. That is the number of the button, actually. This trivial function just assigns a concrete command to that slot. Okay, nothing else. Everything is very, very clear. And one more function, button was pressed. The idea is that this function, called button was pressed, is invoked when you push a button. It accepts one integer parameter. This means that if I push the button number 0, the function button was pressed with argument of 0 gets invoked. And look at the body of that function. What does it do? It just invokes execute function from the corresponding command. That's it. So look, this is a kind of programmatic representation of the remote control device. This control device knows nothing about which actual device does it control. It knows only one thing: execute the name of the virtual execute function from command. That's it. So the interface between the device, this remote control device, and actual devices is only via this execute function. So again, universal remote control device knows nothing about actual devices it controls. Okay, let's go on. This is the same code, the same code snippet, and the explanations. I have already said my explanation. So again, the advantage of the remote control, the implementation of the remote control, is that it doesn't know which action a command will perform. It knows only that for doing an action or invoking an action, it should invoke execute. And as a consequence, the remote control device can be programmed to control any device. The only requirement is that its API should support execute. Okay, let's go on. This is not it. This is only step 2. Let's consider step 3. Suppose we have a concrete device, the light switcher in our room. Usually we use the real switcher on the wall, but now our idea is to assign this switcher to our universal remote control. So suppose this, the programmatic interface of the light switcher contains, looks like this, looks like I have written here. It contains just 2 interface functions, on and off. The semantics of these functions is obvious. Switch the light on or switch the light off. Let's consider how to control this device, light. Look carefully at what I have written. So I have declared a class derived from command. This means that this class must implement execute, pure virtual function execute, or abstract function execute. Look at what I have written in the class. First of all, a pointer to the light device as it is itself, the corresponding constructor that initializes the class, and my own implementation of execute method. It overrides the abstract execute method from the base class, and its semantics is quite obvious. It just invokes on interface function from light. So here we have represented the functionality of light device or device using the rules that were specified by command abstract class. So what did I do? Actually, I've made a command out of a device API. Okay, this was the light device in quotes. Another device, air conditioner. Okay. Well, obviously, air conditioner has a little bit more complicated interface. Of course, it also supports switching on and off. And additionally, it is possible to regulate the speed or intensity of air conditioning. So I've written set speed interface function. Of course, in reality, there are much more interface elements in air conditioning. For example, warming or cooling, or etc., etc. But just for illustrating the idea behind common pattern, I just demonstrate the reduced version of this interface. Okay, and look at the corresponding command. I did the same thing. I made a command out of the API of air conditioning. Again, this command, it is also is inherited from command abstract class. It contains the reference to the conditioner itself. It initializes it. It initializes the command using constructor, and again overriding execute function. What does it do? It doesn't just switch it on. We should set up its speed. Well, I've chosen 20. Suppose this is an average speed of air conditioner for everyday usage. So execute, this version of execute contains two actions, switching it on and setting up the speed. Okay, but the idea is the same. We made commands out of device API or part of device API. Okay, let's consider to have a kind of full, more or less full picture. Let's consider one more command. Suppose I have home music center. It is also programmatic. Therefore, it has some API. Of course, on and off functions with obvious semantics. And suppose I have multifunctional music center, and I'm particularly interested in switching on radio set, which is a part of that music center. So I have the corresponding interface element select radio and a kind of companion interface element set volume of that radio. And my idea is to make a kind of compound action or compound command that would switch the center on, select radio, and set the appropriate volume of that radio. This is the implementation. Again, I did the same thing. I have defined a command with the unified interface out of the interface element of the home music center. Okay, so, and this was again step 3, and now step 4, putting all together. Look, this is how we typically program the universal remote control device. Look at what I have written. First of all, I create the new remote control device, and I apply set functions from its interface, connecting buttons with corresponding actions. You can look back to the interface of remote control and see that the set interface element accepts the number of the button and corresponding command. The specification of the second parameter is that it is of type command, and CMD light, CMD air condition, and CMD radio all have support the interface of command. So therefore, these calls are quite correct. We have assigned actions for buttons. Okay, so what is the result? Suppose a person takes the remote control and presses the second button. The second button has the number 1. What happens after pressing that button? As you might see, the function button was pressed is activated, is invoked. In turn, this function executes the call to execute from the slot number 1. And the execute, as you might see from the previous slide, invokes two functions. It switches on the air conditioner and sets its speed. And the result is that the air conditioner starts working. Again, don't forget the basic idea behind all these considerations. We made our universal remote control device completely independent from the real devices it controls. It knows nothing about which device it controls, no details. And in turn, the concrete device, any concrete device, knows nothing about this universal remote control. It just provides the interface, namely execute. Okay, and now let's make some improvements to this solution. The first improvement is purely technical one, what to do with unused buttons. In my example, I have activated just 3 buttons out of 5. And in general, if we didn't initialize those buttons, we need to check every time a client pushes the buttons number 4 or 5, we should check whether these buttons are initialized anyhow. In order to avoid such checks, we just introduce a kind of pseudo command. I called it cmd nothing. It just performs no actions. Its execute overriding function just has empty body, and we can assign those nothing, cmd nothing instances to unused buttons 3 and 4. Okay, that's completely clear, but we can a little bit we can make this solution a little bit more elegant. Namely, we can initialize buttons at the very beginning by the constructor. Sorry, look at the rest of the slide. Here is the part of the remote control implementation. It's constructor. So initially, we can just assign that that cmd nothing instance to all slots, and after that we can apply set function to set the concrete command to the corresponding slot. Okay, let's go on. Again, I'm going to improve our initial solution. Look, my idea is to add new buttons to our remote control device for switching devices off. You understand that that initial solution was obviously incomplete, because we do have buttons for switching on a device, on devices, but we are not able to use the device to switching devices off. So let's consider the improved version of our device. So suppose we have 5 buttons that switch various devices on, and corresponding 5 buttons to switch them off. Okay, this is obvious and very useful improvement, isn't it? Okay, and the question, how could we program such a device? Look at the next slide. The solution is quite obvious. Within the paradigm of the common design pattern, we just declare corresponding commands for switching off buttons, for light, for air conditioner, and for radio. The implementation of the execute functions for each new command is obvious. We just call the off interface element from the corresponding API, from the API of the corresponding device. Okay, and how does the whole solution look like? Here is the addition. Look at the three last lines from my code snippet. We just assign commands to new buttons. Well, I assume that new buttons have the numbers of 5, 6, 7, and 5, 6, and 7 for simplicity. So the idea of the solution is quite obvious. Well, I don't expect any problems for understanding this solution. Okay, so I would recommend you to check it. Well, we will see my exercises that I suggest to you at the very end of my talk. Okay, no any trouble. I don't expect any troubles on this solution. Next improvement, much more interesting and much more challenging, I would say. I would like, and we all would improve the functionality of our remote control device by adding one more button, which is called undo. Look, now we have this device with on and off button, and it would be quite useful, practically useful, to add at least one more button called undo. Look at the idea. This is my idea. The semantics of such an undo button could be obvious. For example, if I switch on my radio, and well, I have decided to switch it off. I wouldn't like to find the appropriate button on my device. I would prefer just to push undo button to undo the my last action. A lot of similar functionality exists in many real applications, not even on devices, but in any text editor you are using every day. Undo button. So the task: how to implement such an undo functionality in our remote control device. Look at the next slide. The first step, obviously, we have to extend the basic interface, because we need at least one additional kind of functionality. Together with execute for function, we need to have the corresponding undo function. So we have added this function to our interface, basic interface. The next step is to extend implementations of commands appropriately. Simply speaking, we need to declare our own implementations of undo abstract function in all derived classes. Excuse me. Excuse me for interrupting you. So we need to add the appropriate undo implementations to each command we have now. Okay, here is the implementation. Again, implementations are quite obvious. You see, if we switch on the light using execute, so we need to switch it off by undoing, and the same is about light off. If we have switched it off, the undo action assumes switching it on back. Okay, the most important improvement is in the remote control itself. Look at how I modified the implementation of the remote control device itself. First point, instead of one array, the single array slots that contained commands for switching on and off switching on and off devices, I defined two different arrays. The first group of buttons are for switching on. The second is for switching off. You will see why I did this. The next improvement is that I have declared a special member called CMD undo. This is for just undoing. The semantics of this member is that it always stores the latest undo action. Okay, we will see how it works later. Well, I leave the constructor for your own implementation, and let's consider next two interface functions. Next interface function, set. If you remember, initially set was doing just simple thing. It just assigned a command to the corresponding button. Now we do a little bit more complicated action. The function, just a moment. Just excuse me again. Let me switch it off, probably. We have two groups of buttons, commands for buttons. Therefore, set function assigns two commands to on and off commands to corresponding groups of commands. Okay, and next two interface functions. Look at what is changed comparatively to the initial solution. We had only one function that corresponds to pushing button. Now we have two groups of buttons actually, and we have defined two different functions that are responsible for on buttons and for off buttons. Button on was pressed and button off was pressed. Okay, their semantics is quite obvious. Look, what did I write? The first line of these two functions is that I just execute the command assigned to the corresponding button. The number of the button is passed as the parameter. The second action of both functions is that I store the corresponding command with the opposite semantics. Okay, so each time I use my device, CMD undo member stores the action that should be done if I push undo button, actually. And the last interface element, probably the most important one. Everything above was a kind of preparation to this undo was pressed function. It is absolutely simple. The idea is that if I press undo button, this function is invoked. And what does it do? It just performs execute function from the command that was stored in CMD undo. So as a result, we have the appropriate functionality of the undo button. Very good, very adequate, however, a little bit simplified solution. We will see why it is a little bit simplified just on the very last slide of my talk. Okay, and the last point related to the using a command pattern, macro command. Look, before we were working with commands that performed just one single action. The idea behind macro comments or compound comments is that declare a comment that can execute several other comments at the same time, not several interface actions from of the device, but several previously defined comments at the same time. So coming back to the first slide related to the common pattern, this is we can make how to make a queue out of comments to execute several comments at the same time. The idea again is quite simple and straightforward. Look at the code snippet. All I do is that I declare a new class. It is inherited from the same comment interface, and however it is implemented in a little bit different but still straightforward way. I have declared a group of some number of comments within this CMDO class, and I write an add function that can fill that group array, adding different comments to this group. And the key point of this implementation is still our familiar execute function. What does it do here? It simply executes comments from the group array. That's it. It involves execute functions from each comment from the group sequential. That's it. That's it. So this is the way we can make compositions of comments and encapsulate them into the single comment. So the idea is that pressing a button associated with such an instance of such a comment, we can, for example, if I enter my house, my apartment, and push this button, everything happens. The light switched on, the radio starts speaking or singing, and air conditioner starts working. Okay. The key point here, as you already understand, this macro comments still implements the same interface that all other comments. Therefore, it can be assigned to a button, exactly as any other simple comment. And as a reminder, the base class comment, with the base interface, is on the right side, right-hand right-hand corner of my slide. Okay, that's basically it about common pattern. I hope you understand the idea behind it. And my very last slide just contains some exercises. Actually, they are not exercises, but recommendations for you if you want to improve your knowledge and experience with the common pattern. Look, first of all, test my solution. Probably there are some bugs. I cannot say I have inserted bugs intentionally, but to be honest, I didn't check it on my machine. So try to implement my solution and, well, probably improve it somehow. For example, if you remember, we had arrays with fixed size in my code snippets, so you could just try to make the solution more generic, removing and arrays, replacing them for some more advanced data structure. Try to add history to the undo button. Now, as you might see, the implementation of the undo functionality stores only the latest action. And why not to try to organize a history of the previous undos? This would be necessary if you would like to add even more functionality to the solution. Implement the redo button. That, well, the idea, I guess you all understand what means redo button. It just repeats previous action or several previous actions. Think about another application of the common pattern. I have given you just one example, universal remote control device, but perhaps, of course, this pattern is much more generic. It is applicable to many other real needs. So think about another application. And finally, my traditional recommendation, try to draw UML diagrams for the common pattern. Probably you would do that together with your team. So this is it for today. Thank you for your attention, and I would again be with you soon with the next pattern or pattern. Thank you for your attention. That's it for today.